Chapter 4 Thinking. Two stunt pilots are flying to an airshow to join an aerial formation at noon. At 9:30 a.m., the first pilot passes over a navigational beacon, A, at a speed of 200 kilometers per hour and sets a course 40 degrees east of north to go directly to the formation point for a noon arrival. At 10 a.m., the second pilot reaches another beacon, B, located 150 kilometers northwest of beacon A. In solving this problem is to draw a diagram to represent the situation. In the diagram, A represents the location of the first navigational beacon, B is the location of the second beacon, C is the ground point directly below the aerial formation area, and D is the airfield. Important things to remember when solving this problem. Three-dimensional problems involving triangles can be solved using one or more of the following: the Pythagorean theorem, the 6 trigonometric ratios, the sine law, and the cosine law. The method chosen to solve a triangle depends on the known information. To find the length of side C, you have to take into the consideration the information you are given. So the pilot is flying at 200 kilometers an hour, so that in 2.5 hours, which is from 9:30 to noon, which is 12 p.m., the pilot travels at a distance of 500 kilometers. Since the length of the two sides, the 150 kilometers and the 500 kilometers, are known, as well as the angle, which is angle A, you know that angle A would be the 45 degrees plus the 40 degrees, which is 85 degrees. So you would use the cosine law to solve for side A. Now using the cosine law, you would solve for A by plugging in the known information, which would give you the answer of 509.3 kilometers. Once you have used the sine law to find angle B, you would subtract angle B by 45 degrees to get the measure of theta. Therefore, theta is 33 degrees. The direction that the second aircraft must head is 90 degrees minus 33 degrees, or you could say 57 degrees east of north. Therefore, in order to join the aerial formation at noon, the second pilot must fly from beacon B at a speed of 255 kilometers an hour in a direction 57 degrees east of north. Part B. From the diagram, CD represents the distance from the formation point to the airfield and is the base of a right triangle, having a vertical distance of 1.5 kilometers, which is the altitude of the aircraft. So using this primary trigger ratios, we need to calculate the length of CD. So in this case, we are using tan theta equals opposite over adjacent. Tan 10 degrees equals 1.5 over CD. Since you are solving for CD, you must multiply both sides by CD and isolate it. So CD equals 1.5 over tan 10 degrees. Therefore, the length of CD equals 8.506. Therefore, the aircraft is approximately 8.5 kilometers of the formation point. As shown in the diagram, DB is the distance from the airfield to the second beacon. The line is one side of triangle BCD. Angle C equals 90 degrees, or 147 degrees. The angle is contained by sides BC and CD. the lengths of which are known. Therefore, you must use the cosine law in triangle BCD to determine the distance of C, which is from the aircraft to the second beacon. Using the cosine law in triangle BCD, we have determined the distance of C from the airfield to the second beacon, which is 516.45. Therefore, the airfield is approximately 516 kilometers from the second beacon.